scenario dependent. Scenario dependent. The question is, an instance of a subtype can simultaneously belong to more than one subtypes or not? Because there is no yes or no, it depends on the scenario. Because there are two possibilities, so there are two rules. Okay, there are two rules in disjointness constraint. The first rule is known as a disjoint rule. A disjoint rule is that an instance of a subtype cannot belong to more than one subtypes. Okay, so an instance of one subtypes can only belong to that subtype only. Okay, one instance cannot belong to more than one subtypes at the same time. Okay, there is no possibility. If that is the rule, this rule is a disjoint rule of disjointness constraint. The other possibility is that yes, an instance can belong to more than one subtypes at the same time. So if that is the case, that rule is known as an overlap rule of disjointness constraint. So there are two rules in the disjointness constraint. The first rule is disjoint rule, which states that a subtypes instance cannot belong to more than one subtypes, and the other rule is an overlap rule, which is that an instance of one subtype can belong to more than one subtypes. So the notations which are used to represent these rules are D and O. Okay, in the circle, if there is a D, this D represents that there is a disjoint rule of disjointness constraint in this supertype subtype relationship, which means that an instance of patient can be an outpatient or can be a resident patient. Cannot be both, right? A patient can be a resident patient or can be an outpatient, because there is a disjoint rule. Okay, and if there is an O sign used in this circle, it would represent that there is an overlap rule of disjointness constraint, which states that an instance can belong to both these subtypes. So a part can be manufactured and can be purchased. Okay, so an instance can belong to more than one subtypes because there is an overlap rule of disjointness.
So disjoint rule की representation बताओ.
D साइन दोबारा दिखा देता हूँ. देखिए वो ये है. अब इस D का मतलब ये है कि एक पेशेंट या आउट पेशेंट होगा या रेजिडेंट पेशेंट होगा, दोनों नहीं हो सकता. ये पॉसिबिलिटी ही नहीं है. ठीक है. जबकि अगर यहाँ पे O होता, जैसे यहाँ पे O है, तो इस O का मतलब ये है कि एक पार्ट मैन्युफैक्चर्ड भी हो सकता है और परचेस्ड भी हो सकता है, because there is an overlap rule. So we have seen two constraints in the supertype subtype relationship. They are completeness constraint and disjointness constraint. In completeness constraints, there are two rules. The first is total specialization and the other is partial specialization, which is basically an instance of a supertype can, if that instance can exist independently, then there would be a partial specialization represented with the help of a single line. And if that instance cannot independently exist, then there would be total specialization, which is represented with the help of a double line. In disjointness constraint, we further have two rules, a disjoint rule and an overlap rule. Disjoint rule states that a subtypes instance cannot belong to more than one subtypes, while an overlap rule is that a subtypes instance can belong to more than one subtype. So I hope that all these concepts are clear to everyone. Great. So next we have discriminators. Okay. A discriminator is an attribute that is to be added into supertype. Whenever there is a subtype supertype relationship, an additional attribute would be added in the supertype, and the purpose of this attribute would be to identify that to which subtype a specific supertype's instance further belongs. एक सुपर टाइप का इंस्टेंस फर्दर कौन सी सब टाइप का इंस्टेंस है, ये बताने के लिए हमें सुपर टाइप के अंदर एक एट्रीब्यूट ऐड करना पड़ेगा. इस एट्रीब्यूट को डिस्क्रिमिनेटर कहते हैं. Discriminator. The purpose of discriminator is to identify that a particular instance of the supertype belongs to which of the subtypes. So, composition of this discriminator depends upon the previously seen rules, right? If there is partial specialization, पहले हम देखेंगे disjointness rule को. If there is a disjoint rule of disjointness constraint, if there is a disjoint rule means that an instance can belong to one subtype only. So a single attribute is sufficient. A simple single attribute is sufficient because that attribute is supposed to hold one value only, because an instance can belong to one subtype. So one simple attribute is sufficient. Okay? So उस attribute के अंदर the value would represent that instance belongs to which of the subtypes. And if there is an overlap rule, then we'll be having a composite attribute. Okay? And the number of components in that composite attribute would be equal to the number of subtypes. So for example, we have a supertype subtype relationship where there are, for example, two subtypes. The discriminator that is to be added to the supertype, that would consist of two columns or two attributes for both of the subtypes, and their type would be Boolean. Okay? So for example, there is an instance that belongs to both of the subtypes. So values in both of the attributes would be 1. Okay? A 1 would represent that this instance belongs to which of the subtypes. For example, there are two subtypes. So both 1s means that this instance is further an instance of both of the subtypes. 1 and O would mean that this instance belongs to one left subtype only. 0, 1 would mean that this instance belongs to right subtype only. And if both are 0, then it would mean that this instance exists independently. But obviously it is dependent on the completeness constraints. So with the help of disjointness constraint, we'll decide that a simple attribute is required or a composite attribute is required. Further, with the help of completeness constraint, we can apply, if there is a partial specialization, it would mean that both, if there is an overlap, and if there is a partial specialization, then all of the components can have a 0 value. Okay? All of the bits can be false. Okay? Which means that an instance belongs to supertype only. But if there is a total specialization, then one of the column has to be true. Okay? In order to show that an instance further belongs to which of the subtypes. Similarly, for example, there was a disjoint, which means that we are having a simple column, and if there is a partial specialization, then no value would be allowed in that particular attribute. Null value would be a legal value for that attribute if there is a partial specialization. But if there is a total specialization and there is a disjoint rule, then null value would be an illegal value for that discriminator. So this is how these discriminators are added to the subtype. The purpose of these discriminators is to specify that to which further subtype a supertype's instance belongs. And the composition of this discriminator depends upon the rules of the constraints that we have just seen. Okay? First of all, the disjointness rule is seen. If there is a disjoint rule of disjointness constraint, there would be a single simple attribute. And if there is an overlap, there would be a composite attribute consisting of the components whose number would be equal to the number of subtypes. And further, we shall check the completeness constraint, and depending upon that constraint, we will decide either a null value is permitted or not, and either all of the, if there is an overlap, either all of the columns, either can they have a 0 or not.